Newton's method. This one is going to be similar to the bisection method, but this one typically is used a lot more than the bisection method. This is going to be the most commonly used root finding method. It's used quite a bit. I used it all the time back when I was working as an engineer for a defense contractor. Now let's go through the notes here before we go through the actual method. So like the bisection method, this is going to be used to find a solution to this equation. All right, so you've got your function of x, you're going to set it equal to 0, and what you're looking for are the places where the function is going to cross that x-axis. All right, so where the f of x goes to 0. So that's going to find the roots. All right, so we're doing the same exact thing, we just have a different method. Now, f of x has to be continuous, and the solution is going to be near a given point. All right, so you have to provide an initial guess. All right, it's got to have something to work with. So if you give an initial estimate that's way off, you might have some problems. All right, so you need to kind of get a good estimate. And what this method does, this one is going to use tangent lines to determine our estimates. So that's a little bit different than what we did with the bisection method. Remember the bisection method, we had the intervals and we would half the interval and go that way. So this one's going to be a little bit different. So let's go over how this works graphically. And I'm going to attempt to draw this. We'll see how it goes. All right, so let's draw our axes. Okay, so this is x, that's y, and then we're going to draw a function. Right, and every time I try to draw these, I always mess it up when I'm teaching class, so hopefully I won't mess it up here. So let's just draw a function, looks like that. This is our f of x. Right there. Okay, so now we've got that. Now let's go ahead and let's label some points. So let's say we've got this x1. All right, so here's x1 right here. All right, now we're going to come down here. This point right here on this function, we've got our coordinate. It would be x1 and then f of x1. All right, so that would be the coordinate location of that little point right there. Now what I'm going to do is I'm going to draw a tangent line right here at this point. Okay, and it will cross the x-axis. Right, so I know y'all love my ruler, right? This thing is really old, but it was my brother's. I borrowed it and never gave it back. Okay, so let's draw this line right here. So we drew a tangent line to this point, and now it's going to cross the x-axis, right? Okay, so what we're going to do is now we're going to have this point, and let's label that as x2. Okay, now this line obviously has a slope, right? It's a line, it's got to have a slope. So here, let's just put the slope, and the slope, if y'all think about it, is f prime of x, right? First derivative of f of x gives you the slope. Isn't that convenient? Okay, so now we have that. So let's write out in notes here what we did, and then we'll keep going. So we drew a tangent line. That'll be your first step. At the initial guess. All right, I didn't point that out a minute ago, but x1, that is your initial guess. All right, so you have to give that estimate of where you think the root is, and that would be our best guess. Okay, so we did that, and now the x-intercept of that tangent line, oops, that gives x2. So this is going to be kind of our next estimate. All right. So now what we're going to do is we're going to continue on with this same process. So I'm going to go up and I'm going to find my point on the function, at x2. All right, so now I've got this. So this point here is x2 and then f of x2. All right, so now I've got that, and now I'm going to draw a tangent line to that point. Okay. So let's see. Hopefully I can get all this in here. So let's move it over a little bit. So let's say this is tangent. I'm getting a lot of stuff right here. Okay, so this one crosses the x-axis right here, so let's call this x3. All right, now you do the same thing. So we drop down here on our function. We'd have this x3, f of x3, and then if we needed to, we would draw another tangent line, see where it crosses the x-axis, so on and so forth. Okay. So let's finish writing this out. All right, our x-intercept of the tangent line gave us x2, so then you would draw a tangent line at x2 and f of x2. And then again, the x-intercept is going to give you your next estimate, which would be x3. Okay, so that's the basic process. So it's pretty straightforward, pretty simple to do. And let's remember that f prime, let's say of xi, those give the slopes of the tangent lines. All right. So now we've got this. Okay, well, I keep bringing up that we got this slope of the tangent line, right? So there's a reason for that. And let's look at what that is. So since f prime of x1, for instance, equals the slope of a line, and we know from way back when we first started looking at lines, that slope is going to be rise over run. Let's write out our equation for f prime now. So if we've got f prime of x1, we can write that as equal to 0 minus f of x1 over x2 minus x1. All right, now let's go over where we got that. So we already said slope is equal to rise over run. Okay, so this part here is the rise. Remember, we're looking at this line right here. So we're starting here, going here. Now this, the rise value is the y term. So y right here has to be 0, right? So we get 0. And then right here is the f of x1. So that's where we get that. And then the run part, you just want this x distance between x2 and x1. So just subtract those. Now what I'm looking for is I want to know where x2 is. I already know x1 because that was my initial estimate, right? I provided that to the method. So now I need to know where x2 is. So let's just put we want x2. So now let's go ahead and all you're going to do is take this equation and solve for x2. Quick and easy, right? So if we do that, let's just write it out. We'd have x2 minus x1 equals negative f of x1 over f prime of x1. All right, and I want to get x2 by itself, so I'm going to take this, move it back over. So that's going to give me x2 equals f x1 minus f of x1 over f prime of x1. Okay, and this right here is your main equation for Newton's method. All right, so let's write it out where we aren't just using 1 and 2 because it needs to work for all of the different lines. Okay, so we can write that xi plus 1 equals xi minus f of xi over f prime of xi. And this right here is our equation. All right, so this is known as the iteration equation. Newton's method. And that's it. So it's pretty straightforward. So basically what we do is you just keep going through doing the tangent lines and you'll get these estimates, and you keep updating it until you reach a certain tolerance. Okay, and I'll show you what that is when we get to the algorithm. All right, so let's just write down here that this equation will be repeated until a solution is reached. There we go. All right, so let's stop this video here because it's already 12 minutes. We'll pick it up next time and we'll write out we'll look at the algorithm. All right, and then we will look at an example. So I'll see y'all next time.